Hello, Mr. J. This is Glory Tai from Period 5, and this is my air rocket activity. So, for the first rocket, which is the low-speed rocket, this is a diagram that I drew of it at 0 seconds. So, it's at a speed of 0 meters per second, and this is the positive direction, which is up. So, this is a velocity versus time graph that I drew, as well as the acceleration. Basically, I'm going to use these two graphs to figure out 3 to 10. And so for 3, the change in velocity is negative 26.8 meters per second. And how I found this change in velocity is I found the area of the acceleration graph. By finding the area of the acceleration graph, which is meters per second squared times seconds, you get m over s, which is the delta velocity. For number 4, I found the initial velocity was 13.4 meters per second, and I did this by finding the change in velocity divided by 2, because these two sections of the graph will equal 26.8 if I absolute value them. So in order to find the initial velocity, which is right here, I'm going to have to do that, because change in velocity is this section plus this section. And so, yeah. Number 5, is the speed when the rocket was launched different from the speed just before the rocket hit the ground? And I said no. Because the acceleration is constant, where at the midpoint in time, the velocity right here is 0. And so the motion appears. What does that say? So the motion appears to be a parabolic graph if I were to convert this into a position versus time graph. And therefore, the ends of the parabola would have equal. This is actually speed. So equal speed values with respect to time. So the only difference is that the velocities will be different, positive or negative, but the speed will be the same. For number 6, the maximum height of the rocket. The maximum height of the rocket will be 8.978 meters. And I found this by taking this section of the graph and turning into a triangle, and I found the area of this triangle, which equals position, because the area of a velocity time graph is displacement. And for number 7, was the acceleration different when the rocket reached maximum height? Explain your reasoning. And I said that the acceleration was not different, and it remained constant because the slope of the velocity graph remained constant. The force of the Earth's gravity pulling at the object slows as it rises and speeds up as it falls, so that during the free fall, your acceleration at the same height from the Earth will be equal. For number 8, the total distance that the rocket traveled. I got 18 meters, and I did that by taking the maximum height and dividing it by, or timesing it by 2, because by multiplying the maximum height reached by 2, I find the total distance traveled, because the rocket must have traveled an equal distance from the initial point to the midpoint, and from the midpoint to the final point. Because when the rocket takes off from the surface, reaches the maximum height, and then returns to the surface, from that maximum height, it's obviously the same distance, because the Earth's surface isn't a different height at different times. For number 9, what was the total displacement of the rocket? What I got was 0 meters as total displacement, because the final position minus the initial position equals 0, because after all, the rocket did return to the origin. And number 10, are your answers different for the last two questions? Whether the total distance the rocket traveled versus the total displacement of the rocket are different? And I said yes, because 18 meters and 0 meters are different. The displacement takes into account that the motion is a negative direction and the final direction you end up with with respect to your initial position are they're different signs. While the total distance traveled adds distance in absolute values. So yeah, that's for the low rocket. However, all the other speeds of the rocket, most of the answers will apply. So I'm just going to read off my answers for numerical values. So for the medium speed rocket, same diagram. For number 3, the change in velocity will equal negative 43.6 meters per second. Found it the same way. For number 4, I found the initial velocity was 21.8 meters per second, same way I did for number 1, or part 1. For number 5, that was already answered. For number 6, I got 23.8 meters for the maximum height. For number 8, I got 47.5 meters for total distance traveled. For number 9, I got 0 meters for displacement, and for 10, I got yes. For the high-speed rocket, these are my two graphs. For number 3, the change in velocity will equal negative 50.9 meters per second. For number 4, my initial velocity was 25.5 meters per second. For number 6, I got my maximum height as 32.4 meters. For 8, I have 64.9 meters for total distance traveled. For number 9, 0 meters for displacement, as usual. And for the super high rocket, I have these two graphs. For number 3, the change in velocity will be negative 61.9 meters per second. For 4, I have an initial velocity of 31 meters per second. For 6, I have 48 meters for maximum height. For 8, I have 96 meters total distance traveled. I have 0 meters for displacement. And yeah, for 10 and 7 and 5, I have the same answers for everything because they have already been explained. So yes, that is the air rocket activity. Hope you enjoyed Mr. Day. I am done.